I was asked to talk today about this interesting and rather broad question of are extremes becoming more extreme? So we should start by saying what are actually extreme events, and you'll be familiar with many of these. For temperature, for example, we could have cold snaps, which involves icing events. We could have heat waves, these are both atmospheric, and marine heat waves, which could be quite damaging to fisheries. We could also have extended warm periods. So this isn't actually an extreme temperature. This is just a very rare occurrence where we could have high temperatures for a long period. And this can lead to droughts and wildfires. In terms of precipitation, we can have torrential rain, which leads to flash flooding and landslides. We can have extended periods of moderate rain, which can lead to flooding by overwhelming the drainage systems and by oversaturating the ground. We could also have extended periods without rain, and this again can lead to droughts and wildfires. We also have storms, and these we're quite familiar with here on the coast of Norway. These bring with them extreme winds, storm surges, which lead to coastal flooding, and torrential rain. So these are just some examples of what extreme events look like. But how do we actually identify extremes from these? Well, there's a couple of different approaches we often use. The first is we define some sort of threshold, which is very high, and any event that occurs above this in magnitude, we consider an extreme event. The other is to look for something that's a rare event. So this is when we look at a distribution of probabilities, it would be something that occurs in the tail of the distribution. Now, as researchers, we like to have a hypothesis. That is, we like to have some expectation of what we're going to see before we go looking for it. So what do we expect to see here? Well, in terms of probability, we can think of the distribution shifting in mean, so just becoming slightly more positive. This, for example, would be the world warming by 2 degrees. We could also consider the possibility of the distribution changing in shape. So this would be an increase in the variability, the day-to-day temperature range. And this would have the effect of pushing some of the probabilities out and into the tails. Both of these will lead to a disproportionate change in the occurrence of extreme events. More interestingly, they lead to two particular types of changes. The first is that as the tail of the distribution extends beyond where it was previously, we could start having events we've never seen before. So these are unprecedented extreme events. Also, as the tail fattens up, this increases the chances of events occurring. So events that we're used to occurring could occur with a higher frequency. For example, an event that occurs once a century might start to occur once per decade. So is this actually happening? Well, when it comes to extreme temperatures, the answer is pretty solidly a yes. Extreme temperature events are increasing in frequency, magnitude, and duration. Since 1970, global temperatures have risen by around 0.2 degrees per decade. That's around a 1 degree of warming in the last 50 years. The last 5 years have in fact been the hottest 5 years on record. And all of these changes together have meant that a lot more people are being exposed to extreme heats and things like heat waves. When we bring this down to a local level, something like Europe, the situation becomes much, much worse. Since pre-industrial times, we've seen warming of 1.7 to 1.9 degrees. That is, we talk about a 2-degree warming world, but within the next few years, we're going to start seeing a 2-degree warmer Europe consistently. The warming, however, is split geographically and seasonally. So in the summertime, the strongest warming is in the south. So this is southern Europe, particularly the Iberian Peninsula. Whereas in the wintertime, the strongest warming is in the north, so northern Europe and Scandinavia, leading to a lot more wetter and milder winters, which is not good news for skiing. In terms of extremes, we all know that there's been a lot more heat waves over the last 2 decades. Everyone, I'm sure, is familiar with the heat waves that struck in Paris in 2003 and the one that affected Moscow in 2010. But in 2019, the heat wave of June and July was particularly strong and broke records across many countries. As the figure shows, the maximum temperature on just one day in July meant that most of Europe was above 25 degrees Celsius. And Paris that year reached 45 degrees. That's basically unprecedented. So what about precipitation? Well, global warming increases the intensity and frequency of extreme precipitation events, but there is a lot of geographical variation. So in some places, we are seeing a significant reduction in the extreme precipitation events. You'll notice the map has a lot of white areas, and this is because the data just doesn't go back far enough in those places. So although there we might be seeing what we think is an increase in extreme precipitation events, we just don't have the historical records to compare to know whether or not it's really happening. When we bring this down to Europe, there has been a significant increase in extreme precipitation events over northern and eastern Europe, and a decrease in precipitation events over southern Europe, Mediterranean, particularly again the Iberian Peninsula. Interestingly, the intensity of the extreme precipitation has increased, even for places with decreasing frequency. So that is, a place like Spain is getting less extreme precipitation events, but when they occur, they're more intense than they used to be. In general, over Europe, the number of days with extreme precipitation has increased by around 45% since the 1950s. Now, one of the problems of changing the probabilities and increasing the occurrence of these events is that we're increasing the chances of having multiple events occurring at the same time, or of having an event occur when there is a background which is very favorable to this and will amplify the impacts of that event. And these we call compound events. The IPCC has laid out definitions for 3 different types of compound events, but I'll give you a couple of quick examples now. The first is we can imagine a situation where we have snowfall and the land is covered by snow. We have a snow-covered surface. We then have an extreme precipitation event, so heavy rain. This rains onto the snow, and the snow helps to amplify the amount of water coming out of the system, and hence we get a much more intense flooding event. A different type of compound event is when we have a low-pressure system off the coast. This can lead to heavy rain in 1 or 2 catchment areas. As that water tries to run off the land and out to the sea, the problem is that the low-pressure system is also causing a storm surge. So it's effectively rising the sea level at the coast and flooding the coastal areas. And these can combine to create very catastrophic flooding events along the coast. One thing we can say about extreme events is that the impacts of these have been increasing. The United Nations recently released a report looking at the disasters associated with these sort of natural events. And they compared in that the first 20 years of this century to the last 20 years of the previous century. And as we can see from the top diagram, just showing the number of disasters related to these events, the extreme temperatures, the floods, the storms, all of these have increased in number. Furthermore, we know that floods, droughts, and storms make up about 90% of the natural disasters affecting people worldwide today. So back to our question then, are extremes becoming more extreme? Well, it's a very broad question, and given all of the statistics involved, I would say the best answer might be probably. It very much depends where you're looking and what you're looking at. In some cases, it's a very clear change that we've seen. In others, it's not quite so clear. But hopefully, I've given you some idea of extreme events and how they're changing in the current world. Thank you.